We wanted to replicate the magical talking hat of the Harry Potter franchise. To do so, we identified 4 stages of this project: detecting a wearer, sorting into the appropriate house, announcing the chosen house, and synchronizing the hat's movement with its dialogue. Now, some of you may recognize this project. For embedded systems, we wanted to improve the prototype we had at the end of hardware software. Here enter Sorting Hat 2.0.
So we had our project requirements to do. We had 4 inputs. The SD card, which is for containing the data for his speech, basically how he's going to talk. Motion sensor for when he's supposed to turn on. The thermistor for helping determine house selection based off, how much heat somebody's giving off. Batteries. So for our 4 outputs, we had, of course, the speaker, the servo motor. We wanted LEDs to light up to determine the house selection, and we wanted a fan. We wanted a fan that would kind of cool down the inside of the hat because we're dealing with temperature.
So, where shall I put you? You're just a model. Says talent. Oh, I said, yeah, that's interesting. It's all here in your head. You're true and unafraid of toil. Said to me, applesauce.
We wanted him to talk, which we have done. He actually does have a speaker. Inside there is a hefty servo motor that helps him move with a lot of wire and structure to help him move. So our SD card is in our Wi-Fi shield on our Arduino Duo, connected to a speaker. On the other side is all the components for the speaker. So you have capacitors and other things like that help amplify and boost with the potentiometers kind of being the volume control. We have the thermistor dangling from it to determine house. On the back, we have the motion sensors, which turn on the Arduinos.
This was the first new addition to the hat. The thermistor reads the temperature, such as ambient body heat of the user, to determine the resulting house decision. This improved the randomly assigned function by personalizing the house selection using a user's temperature. This feature was implemented mostly before the shutdown.
So let's talk about the Arduino Duo. So this was originally the Arduino we chose because we discovered we could actually build a speaker based off it, because it has, if you see right there, a DAC 0 and a DAC 1 pin. A DAC pin is a way to stream data in and out consistently, so you could play things like audio files and other things like that through the Arduino Duo. What we didn't know is that the Arduino Duo is a kind of experimental Arduino, and it doesn't have some of the, even though it looks like a Mega, it doesn't have some of the capabilities, or it's vastly different in how it operates.
The Arduino Duo makes decent audio quality possible. However, we did not foresee the problems it would present in later parts of the project. We wanted to add LED lights to the Hat 2.0, which would indicate house result by color. This would require an input interrupt. We could successfully implement this individually using the Uno. Unfortunately, we could not meet up to implement this on the hat itself. Here instead is a demo of the LEDs, which would take a house decision from the thermistor as follows.
Here's a quick rundown of the code. This one right here is the long timer. This is the short one, so we cycle through a bunch of this right here. Ooh boy. Cycle through a bunch of this, and then when this one times out, we stop doing the flashing. This is the main variable that holds the actual house, and then these are all the pins for the colors. Alert house is a switch statement. It takes the first letter of each house here and sets what color is supposed to be triggered, and then sets both of the timers. And then there's two ISRs. There's the short-term timer that changes back and forth so that the lights flash, and then the long-term timer here. So here's this. I'll just go up here and type an S, hit enter. So when I hit enter on that, can't quite tell, but it is flashing here to an H for Hufflepuff, or maybe.
We have a basic balsa wood and wire structure inside, just do proof of concept and whatnot. Servo motor's kind of locked in there now, but we wanted to get 3D printed structure on his insides and actually make him move even better because, as you'll see, just the way he moves right now, it's a little basic, and we wanted to kind of enhance that. Unfortunately, yet again, we were not able, all of a sudden we lost all access to our 3D printers and other resources that we couldn't do that.
Here, you can see the basic concept of the structure. We created a simple STL file to prototype what we could have done. This would have provided a better structure around the motor, making motion more defined and possibly quieter. This also would have made the hat much more durable than its current balsa wood base.
So the hat movement, there's a beefy 40 or 45 gram servo motor in there. We actually had to upgrade it because the original structure and everything would actually strip the plastic gears in the basic Arduino kit. So we actually had to get a nice beefy servo motor with metal gears in there. And that was actually, it works really, really well. The problem is the motor's so powerful that when it was connected to the do, it would cause tons of feedback. And actually, when we demonstrate, I'll actually even show, you can still kind of hear the hum in the background. But unfortunately, here, the few things that we did run into is, one, the Arduino Do doesn't play well with others. So when we originally tried to have the servo motor connected to the Do, but the servo motor caused such interference in the speaker, we had to have it separate. So we tried to master and slave the Arduino Do to the Arduino, but in quick research, the master logic is 3.3 volts in the Do, and it's 5 volts in the Uno. This means if the Do requests information from the Uno, and the Uno sends information back, because this is sending back at 5 volts, it could actually burn out or damage some of the I/O pins in the Do. So we couldn't even have that. So that's why there's 2 motion sensors, because I set it up so that they time together the motion and the speaking.
Unafraid of toil. Better be Hufflepuff.
In spite of the lockdown, our group managed to accomplish quite a lot. You can see here that our plan for what was going to happen versus our plan for what actually happened during the lockdown is almost the same. We accomplished about 90% of what we promised at the beginning of the semester. We successfully modified the project to adhere to as many of the guidelines as we could while socially distancing. We implemented a timer interrupt with the LED, which we already explained in this video. We also made the house selection smarter with the integration of the thermistor, which used the user's temperature to personalize the process. We implemented a fan as the hat's 4th output. Building all these parts into the hat itself was impossible due to socially distancing guidelines, but these parts are programmed and work individually. Our only significant loss with this report, as a result of the COVID lockdown, was an improvement of the hat's inner structure. As we previously discussed, our plan was to 3D print the structure and replace the current balsa wood base, although the strength of the balsa wood base surpassed the team's expectation and holds the hat together in a sufficient manner. This project was made possible with the support of the Embedded Systems faculty and viewers like you. Thank you.